Camera components, theory of work and its specifications. The camera is made of three basic elements: an optical element, the lenses, a chemical element, the film, and a mechanical element, the camera body itself. In modern digital cameras, as in smartphones, the only different component is the film, which is replaced by camera sensors that will be discussed later. As we will see, the only trick to photography is calibrating and combining these elements in such a way that they record a crisp, recognizable image. Firstly, for the first component, the lenses. The optical component of the camera is the lenses. A lens is just a curved piece of glass or plastic. Its job is to take the beams of light bouncing off an object and redirect them so they come together to form a real image. An image that looks just like the scene in front of the lenses. But how can a piece of glass do this? The process is actually very simple. As light travels from one medium to another, it changes speed. Light travels more quickly through air than it does through glass, so a lens refracts and slows it down. When you turn the lenses of a camera to focus it, you are moving it closer or farther away from the film surface. As you move the lenses, you can line up the focused real image of an object, so it falls directly on the film surface. Secondly, for the film. The chemical component in a traditional camera is the film. Essentially, when you expose this film to a real image, it makes a chemical record of the pattern of light. It does this a collection of tiny, light-sensitive grains spread out in a chemical suspension on a strip of plastic. When exposed to light, the grains undergo a chemical reaction. In black and white film, the developer chemical darkens the grains that were exposed to light. This produces a negative, where lighter areas appear darker and darker areas appears lighter, which is then converted into a positive image in printing. In color film, it has three different layers of light-sensitive materials, which respond in turn to red, green, and also blue. When the film is developed, these layers are exposed to chemicals that dye the layers of film. When you overlay the color information from all three layers, you get a full color negative. On the other hand, the modern digital cameras, it uses sensors which are more closely resembles a solar panel than a strip of film. Each sensor is divided up into millions of red, green, and blue pixels, i.e. megapixels. When light hits the pixel, the sensor converts it into energy, and a computer built inside of the camera reads just how much energy is being produced. Measuring how much energy each pixel has allows the sensor to determine what areas of the image are light and dark. And since each pixel has a color value, the camera's computer is able to estimate the colors in the scene by looking at what other nearby pixels registered. Putting the information from all the pixels together, the computer is able to approximate the shapes and colors in the scene. If each pixel is gathering light information, then camera sensors with more megapixels are able to capture more details. That's why manufacturers often advertise a camera's megapixels. While that is true to some extent, the size of the sensor is also very important. Larger sensors will gather more light, making them better performers for low light scenes. Packing lots of megapixels into a small sensor actually makes the image quality worse, because those individual pixels are too small. Camera specifications and manual control. The main specifications and manual controls are megapixels, exposure, aperture, shutter speed, and ISO. We have already explained megapixels, but for exposure it is the amount of light which reaches your camera sensor, or the film. It is a critical part of how bright or dark your pictures appear. So actually, exposure is complicated as it depends on many factors distributed over the following factors. Firstly, the aperture. The aperture is simply the opening within the lenses that limits the amount of light that can pass through it. By changing the aperture value, you increase or decrease the size of that opening, thereby allowing more or less light into the camera. Aperture is measured in f-stops, such as f over 16, f over 4. But here is the thing, the smaller the f-stop, the larger the opening and vice versa. Secondly, the shutter speed. Just like the shutters on a window, a camera's shutter opens to allow light in. The shutter lives just in front of the imaging sensor, and the shutter speed is the amount of time it stays open, just like 1 over 60 seconds. Aperture and shutter speed work together, whereas the aperture determines the amount of light that is coming through the lenses. The shutter determines the length of the time the sensor will be exposed to that light. When you set the shutter speed usually measured in fractions of a second, like for example 1 over 30 or 1 over 1000, you are telling the camera how quickly or slowly to open and close the shutter. A shutter speed of 1 over 4000 seconds is very fast and will let in very little light, while a shutter speed of half second will let in a lot of light. Lastly, the ISO. The ISO is the short name given to the International Organization for Standardization, but its meaning in photography is unique, also known as film speed. It is a rating carried over from the film days, but means the same thing on digital cameras. ISO controls how the sensor responds to the light it receives from the shutter and aperture. A high ISO leads to a brighter image, whereas a low ISO will be darker. At the end, some key points to take fantastic shots manually like professionals. First one is to blur the background of a portrait, choose a large aperture, a small f number. To keep the entire image in focus, choose a small aperture setting or a large f-stop. A second key point is to freeze a moving object like a moving car or a rotating fan, use a fast shutter speed. For a blurring effect, use a slower shutter speed. Another point is a tripod is handy when shooting images at a very low shutter speeds. The next point is to reduce the noise. Try to always keep ISO as low as possible, but know you may have to raise it in low light settings. Changing one setting affects the others. If you are using a slow shutter speed, you will likely need to use a smaller aperture to compensate this effect. If you don't mind handing over some control to the camera, choose aperture priority mode to only control depth of the field, or shutter priority mode for motion capture. There is no wrong way to take a photo. Experiment with the settings until you get the shot you are happy with.